So, when I wrote the talk that I gave for the last year at an event apart, Grid Layout was still a hopeful, coming soon feature. And those of us who'd been talking about it for a while, we were pretty sure it would ship into browsers in 2017. We just didn't know exactly when and which browsers. We were pretty sure that Chrome would be ready, and probably Firefox. But what about Safari? We knew the code was there. It had been developed by the team at Igalia as they worked on the Chrome implementation, but would Apple ship it? And then, in March 2017, Firefox, then Chrome, then Safari, including iOS Safari and Opera, shipped within a couple of weeks. And we all gave Edge the side eye. And in October, Edge shipped their updated implementation. So this huge spec is now available for us to use in all of the mainstream production browsers. And I'm obviously very happy about that. It means that I'm not going around the world talking about CSS vaporware. But on a few podcasts and so on since, I've been asked, what it was like seeing it shipped. And here's the thing, while I'd been writing and speaking about Grid and teaching it for years, other than my site of demos, Grid by Example, I'd not built a production site in it, and neither had anyone else. And within 3 months, we were seeing 70% of browsers with Grid support. One of my sites very quickly had almost 90% of Grid support. And all of a sudden, it wasn't just myself and Jen Simmons who were talking about Grid. Everyone was talking about Grid. And I got a lot of email. Because people realized they needed to know more about this. And while before launch, I could pretty much answer the few questions I got. There was absolutely no way I could deal with the absolute avalanche of email I got as Grid shipped into browsers and people wanted to know about it. So I kind of started writing more stuff, just answering those questions for everybody, really. And the email showed me a few things. People were really excited about Grid. They'd started to play with it, and they saw what a game changer it was going to be. People were pretty confused. Sometimes they had completely different ideas about what Grid Layout was going to be. And some people were quite scared. They'd just learned flexbox, and now here was this whole other new thing they were going to have to learn. And while I was putting together this talk, I put out a survey, and I'll refer to some of the findings throughout the talk, but one of the questions I asked was, how do you feel when you see a new CSS feature announced? And among those responses were things like this, worried about falling behind. That was a very common response. And this is sad. I'm excited, and I share it with my colleagues, and then they pick it apart. And oh no, a new way to have inconsistencies between web browsers. And then just really sadly, tired. But perhaps some of you can identify with that sort of feeling, a feeling perhaps of being overwhelmed, of being tired, getting excited, getting knocked down, perhaps worrying that browsers won't support these features. And something else I get, and I still get a lot of people emailing me, asking me to kind of rubber stamp their choices. Should I use Grid? Should I not use Grid? Should I do things in this or that way? And the thing is, I can't do that. Because while I can listen to your problems and maybe offer a bit of generic advice, I'm not there in your situation with your team with your particular set of requirements. I can't tell you how to implement Grid, or even if you should in your situation. But what I can do is, I hope, go one better. What I can tell you is that you can get to a point where you can be the person who can make those decisions for yourself, where you don't need someone like me to say it's okay, where you don't need your kind of choices rubber stamping, and you can explain them to your boss or your colleagues or your clients, because that's where you really want to be. You want to be the CSS layout expert on your team. And so how do we get there? Well, that's kind of what this is all about. It's about Grid and new layout, because that's what I talk about. But it's also about routes to navigate real understanding of these things so that you can run with this stuff and use it in the way that's appropriate for your projects. And also that you can use anything new that turns up in the future that you might want to start using. And there's going to be a whole bunch of code. It's all there in the slides and in your resources. You can go and look at that code. So dig into this stuff later and play around with it. So let's get started. And here's the bad news. There's no shortcuts. You do need to understand CSS. There's no shortcut or magical tool for just understanding the nature of the language that we use. But that doesn't mean you have to understand, become like some kind of walking encyclopedia of properties. You don't have to be that. I'm not. People on the CSS working group are not. There are very few people who really understand the breadth of this thing. I do layout. I know a lot about layout. I can quote bits of the spec at you. Just try me later at the party. But I don't know very much about animation. I have to look that stuff up every time I need to use it. But looking up properties and values isn't kind of everything. That would be a bit like only learning some vocab in a foreign language. That kind of works if you just want to sort of announce that you want coffee or beer. But then you can't kind of deal with the response that comes back. You need to get a handle on grammar and sentence structure to be able to cope. And CSS is the same. You can know some syntax, you can know how to look things up, you can know how to put them into a style sheet, but unless you understand the underpinnings of the language, it's very difficult to make that flow. So what are those core things today? What are the concepts that we need to understand if we really want to make layout work for us, to make sites that really work well for people with the flashiest browsers, right down to those with limited bandwidth and simple devices? And I'm going to go through some of those things, and I think you'll probably already know some of them already, even if you don't know what the words for them are. But let's start at the beginning. Cascading style sheets. That first word is really important, the cascade. Now, I know some people really don't like the cascade and wish it would go away, but love it or hate it, if you're going to write CSS, you need to know about it. And you can't really talk about the cascade without talking about inheritance. Inheritance is really important. It means we can put a font on the body and we don't need to declare it on every other element going down. They all become Helvetica if we've specified Helvetica on the body. That's really important to CSS. And you can't talk about the cascade and inheritance without encountering specificity. Because in a situation where several rules might affect one element, we need to decide which one is going to win. That's all it's about. And I'm not going to really head down a rabbit hole of these things today, but if you think you might be a bit fuzzy on how they work, then head over to MDN. There's a really great article there which just goes through how these things work. It'll not take you a great deal of time to go through, but it'll kind of clear up all those little situations where you think, why on earth is that ending up like that? Why is that being inherited? Just understanding how the cascade works is so important. And then if we come to layout, when we talk about flexbox and grid, we often talk about the two axes along which our content will run. We talk about flexbox being one-dimensional and grid two. And those axes correspond to the block and inline dimensions. So in any writing system with a horizontal writing mode, whether your text is left to right, like in English, or right to left, like in Arabic, the inline dimension is along the rows of content, left to right or right to left. And the block dimension runs down the page, the way the blocks are stacked up, where paragraphs or what have you are stacked up. So when you see mention of the inline or block axis, when you're talking about grid and flexbox, that's what it means. If I'm aligning something on the block axis, I'm aligning it in the direction that the blocks stack up on the page. And so if we have a vertical writing mode, then the inline direction is top to bottom, and the block dimension runs horizontally. So in grid layout, block axis is the direction blocks are displayed down the page. Inline, the direction that words run in a sentence. Now, flex layout gets a bit more complicated because of the fact we can have a flex direction of row or column. In flexbox, therefore, it makes far more sense to refer to the main and the cross axis. The main axis is the one that you've set flex direction, that's going to be your main axis. So by default, that would be row and therefore the inline axis. The cross axis runs down the columns. And the reason we don't say top and bottom and left and right anymore with these layout methods are hopefully kind of obvious in the way I introduced the topic. The inline axis is only going to run left to right if we're working in a language that runs left to right with its sentences. The block axis only runs top to bottom if we're in a horizontal writing mode. So that's the different dimensions. Another thing that is important is size. It's become very obvious to me over the last year or so that no one understands anymore how big anything is in CSS, what the natural or intrinsic size of things on the web page are. And this matters because we're moving from a world where we controlled the sizing to one in which we're allowing the browser or even the content to kind of make those decisions for us. So this is what I mean. This is what we need to do if we're going to create a grid out of floats. Now this is simplified, but it's what any float-based grid system does. So you might be using Bootstrap or Foundation or something you've rolled yourself, or you're using SAS to work this stuff out. If you're using something where maybe you apply classes to items to say, please span 2 or 3 columns, and you're using floats, it's doing something like this under the hood. We've got a row wrapper, which stops things from popping up into the wrong rows. And we give everything a percentage, including the gaps between items, which is a percentage margin, and then we add up those percentages to get items which span multiple tracks. And what we're doing here is we're working out the sizes of columns plus any gutter and sticking that percentage into the CSS. As long as we don't end up with more than 100% in a row, and we've got these wrappers round, so if we've got any gaps, things don't hop up and fill the gap, we get something that looks like a grid. And looks like a grid is the key thing. It only looks like a grid because we've carefully worked this stuff out. And we're working it out row by row. And by doing that, we can make things line up and they look as we want in our design. They look like some kind of grid. And it turns out that percentages, they look horrible in our CSS. They're not exactly fun to calculate, but they're very understandable. We can work out what percentage value we need to pop in based on an ideal pixel size, which is using the method that Ethan Marcotte worked out in his seminal piece on responsive design. We understand that, well, if we have more than 100%, bad stuff is going to happen to our layout. But we're doing the work to figure that out, either with a calculator on the desk, or using some tool or framework, or perhaps calc in CSS, but we're in control of doing that. And when we talk about new layout, we say, well, one of the great features is that you don't need to use percentages anymore. You don't need to have these ugly things in your CSS. But when you start playing around with things like flex basis and playing around with the FR unit in grid, sometimes you find that things don't quite behave the way that you thought they were going to. They don't seem to be as dependable. And in fact, one of the objections people raise against grid layout is they'll say, well, I can do all of this already in Flexbox. I can make a grid in Flexbox. And you absolutely can fake a grid in Flexbox, just like you can fake a grid with floats. And you do that by restricting the flexibility of Flexbox. You give everything a percentage size. You return to doing the calculations by yourself. Now, it's an improvement over floats, because we don't need to do any clearing, and we can take advantage of all the nice alignment stuff that we have in Flexbox. But we're doing pretty much the same thing. We're still faking a grid by lining things up. And that's super important to understand as you're transitioning to grid layout. The difference in layout models. The fact that with grid layout, we have a grid, and we place things onto that grid. Everything that came before involves us making something that looks like a grid by giving things sizes, lining them up, and pushing them around. So, this new world does bring us some challenges, and sizing that suddenly starts to seem a bit more complex than this ugly but understandable percentage. So we need to have a look at this new world of sizing. And here we need to look at this impossible to say on stage CSS intrinsic and extrinsic sizing specification. This is the specification that tells you exactly how big that box is. It deals with the intrinsic size of things, which is the size their content would have them be if there weren't any external influences, such as a parent item restricting their width. And it deals with the extrinsic size of things, which is the size they are based on those external influences, or perhaps you've given that thing a width. So let's have a look at a string of text and just see how those things act. I've got a div, and inside that is my text, and I've given the div a border so we can kind of see the extent of it. So a div is a block-level element, and as such, if we apply no sizing to it, our box will stretch out as far as it can go, And so we're in English, we're in a horizontal writing mode, so it's doing that in the inline direction, it's going as wide as it can do, and it's hitting the viewport or any container that it's in. We know that's kind of how divs behave. Now that container, or the viewport, is providing an extrinsic size for the item. It's causing the box to be a certain size. We could ask our box to be a specific size. We could add a constraint to it. So I could say, well, I would like you to be 500 pixels wide. In that case, our div is going to become 500 pixels wide, and if there's any text in it that needs to wrap, it will wrap inside that container. So we end up with this. So here we're telling it how big. And a percentage is pretty much like a length in CSS. Most things that accept a length accept a percentage because that can be easily resolved to the same thing as a length. But the content of our box has a size. And perhaps we'd like that content to dictate the size rather than have something external constraining it or putting a length of some sort on the div. So the maximum size of our string of text would be if it didn't wrap at all. So if it all stretched out on a single line and no sort of soft wrapping happened, that's going to be what we call its max content size. So CSS knows this is the max content size, as big as it can get, even if it causes overflows, even if it's going to cause a scroll bar on the viewport. That's its max content size. The string also has this min content size, a minimum size. And in that case, it needs to wrap everywhere. It sort of wraps in every little option it can, all the soft wrapping opportunities. And really, if you've got a string of text, that means it's going to become as big as the longest word that's in that string. And that's its min content size. Now, we've actually got keywords that let us use these. They haven't got super browser support yet to be used as a value for width, but you can do that. So we could say width min content. And that would actually cause the box to become the min content size. It's now taking all of its soft wrapping opportunities and trying to get really, really small. If we use max content, it does the opposite. So now it's become as wide as it can do if none of those soft wrapping opportunities were taken, but it doesn't take any extra space. It doesn't sort of spread all the way out. So I want to show you what happens if we have something at max content that also then is constrained by something with a width. So here I have put my box into a fixed width container. The outer container is set to 20M, and the box inside is set to max content. So we now get this overflow situation, which tends to be not what you want. And that's why content on the web uses fit content sizing, and we used to refer to that as shrink to fit. It kind of gets as big as it can do into its box, and then it starts doing wrapping, so it stays inside the box. And we try not to cause overflows. And all of this might seem a little bit academic. As I say, those content keywords are things you may well find useful themselves. But it is all really important when we start to think about flex and grid layouts, because those layout methods use those min and max content sizes when they try and work out how big things are, when they try and work out, how much space have I got to stretch into, or what do I need to shrink into. So let's have a look at what flexbox does with this. So this is flexbox. I've got my content here. It's marked up as a set of divs inside a wrapper that's going to become my flex container. And they're going to do what flex items do by default. They're going to display as a row, and each of the items will try to go to max content size. So we can see that on the top row of items. Our items there, they're smaller than the container, so there's enough room for them all. They all go to max content size. They're not wrapping at all. But if we add more content to one item, as we do in the second example, we haven't got enough space for everything to be at max content size. So how does Flexbox work out what to take away from the items? Well, what it does is it starts at max content size. It looks at, well, how much space do I need if everything just spread out to be as big as it could be? And then we've got all that content, and so Flexbox starts to remove space from the items so they're going to fit into the container. And it does so in proportion according to their flex basis, which by default is auto. Auto looks at the content size, and we know that's gone to max content. So our flex basis for the larger item is much higher than it is for the smaller items, which means that the larger item gets more space. And so our smaller items have space removed till they get to their min content size, then they stop because we're not going to shrink them down to nothing, and then the rest of the space is taken away from the larger one. And that's why we don't end up with 4 equal width columns if your flex basis is auto. And we can start to control this behavior by using flex grow, flex shrink, and flex basis. And knowing about sizing helps them to make sense. If we want the items to fill the container when there is extra space, then we could use a flex grow of 1, flex shrink of 1, and a flex basis of auto. Now in the first case, we've got extra space, so the items spread out, and we get what looks like 4 kind of equal width items. The second case doesn't change because we had no space to grow into. There was no growing occurring, so we just shrunk as we did before because we need to shrink in that case. If you do want equally sized items, no matter how much content is in the item, then you don't want growing and shrinking from auto. What you want to do is grow and shrink from 0, because then you're saying each of these things has no space. Let's share out all the space equally. And that will then cause equal width columns, but it means that you end up with your item with lots of text in being a lot taller than the others. But if we take a look at this algorithm in grid layout, it works in a similar way, but with a tiny difference. And that difference makes things look different. On this slide, I'm comparing the layout we end up with flexbox and grid. Because in grid layout, the algorithm works by taking the min content size and adding space in proportion, capping each one at max content. So because our small items get space added rather than taken away, they very quickly get to their max content size. And you might never run into those differences. But if you do, having some idea of the fact there's an algorithm going on under the hood, there is something specified doing this. If you look in all the browsers and they are all doing the same thing, then it's probably because the spec has told them to do it. And so you need to sort of look into why that might be so, because that's where you get your layout superpowers, is in digging in and finding out why we're doing certain things. And now we've got some idea of what's going on, we can look at the various ways that we can play with sizing in our grids. Those content keywords I mentioned earlier, they might not have great browser support to be used for strings, but they're great for using to set track sizes. And everywhere that supports grid layout also supports those keywords for your tracks. So here I'm going to have 4 tracks, all at min content size. And you can see how each track has become as small as it possibly can do. The long text is wrapped wherever possible, and that's defining the size of that track. We can make our tracks as big as they could possibly be, although that might cause overflows, by using max content. And you can see how the grid with only small items has gone to max content size. It's still got room in the grid container, they're absolutely fine. The second grid has the longer text in, and an overflow has happened. Because it's max content, we're saying, well, don't do any wrapping. I want you to poke out the side like that for whatever reason. We also have fit content in grid layout. Now, that's an incredibly useful sizing keyword that can be passed a value, and that value is kind of the maximum size you want to grow to. So here I'm passing in 15ch, which will stop the track growing at around 15 characters of space. Now, all of those tracks are sized the same way. But in the top section, none of them reach the maximum value, and so they just go to max content, because that's what fit content does. It gets to max content. If there's no more, it just stops there. And in the second example, our long text reaches that limit, and so it stops growing at that side and starts wrapping. And the reason to kind of understand this stuff, let's have a think about those 12-column grids again. You can absolutely make a 12-column grid if that's what you want to do, or a 16-column grid. And you might want to do that. Perhaps you add in grid elements to an existing design. Your grid layout grid will be a much simpler construction because we don't need any row wrappers, and we don't need to push things around. Instead, we could just add all of our sizing to the container. So we make our grid using FR units and fixed width gaps. The thing to remember with grid, that unlike our previous layout methods, you can let grid just work out the sizing for you. Meaning you can use fixed length unit for gaps if you want to. Grid will take that away before distributing the available space. And so that's really all we need. That's our grid. That's the only code that we need there. And you can still use percentages for your column gaps if you want to. An excellent reason to do so is if you're adding grid layout components to an existing design, which has to use percentage sizing for the other elements in the design because they're using older layout methods, and you want your grid to line up with those. If you use percentages in your grid, then they'll all line up. But otherwise, I would probably be looking at using the FR unit in the way that grid distributes space. It'll make your life easier ultimately. But also remember that you don't have to stick to a 12-column, 16-column grid. This quote is from an article by Mina. The article is about the redesign of Slack.com. They noted that they'd started out trying to create a standard 12-column grid, then realized they didn't need to do so. Grid enabled more flexibility than that. So instead of worrying about these fixed sizes, we can create components that are content aware. So here's a really simple example of that. I've got a media object here, a very, very simple thing that we have all over our designs. What I'd like is to have one bit of code. And if it has a big image in, an image which is bigger than the track that it's in, I'd like the image never to be bigger than 300 pixels. So if someone puts in a 500 pixel wide image, it should size down with max width being 100%. But if I have a little image, like an icon or something, that's actually only small, then it should only take up the space it needs. I don't want a big gap in between a small image and that 300 pixel track. So I want to do this with one component. And I don't want to have to add classes and say, oh, this is a bigger image or a smaller image. So we do that with fit content. We set a max of 300 pixels on fit content, and then we make the second track 1FR, and that will just take up any available space. Whatever's left, that 1FR track will have. And I love making these little flexible components and taking stuff that maybe previously in a design system had 2 or 3 components to sort of cope with the different sizes that went in, and working out how I can do it with one component by using these sort of intelligent content sizing aware track sizes. I also love creating these very precise looking layouts with elements that can expand if the content needs to by using min-max. So here's some grid code. I've got 3 columns and I've got 5 row tracks, and my row tracks all have a minimum size. Because I'm working in English, that's a height, so I've got some that are 100 pixels tall and some that are 50 pixels to make space in my design. And the whole layout is a single grid. The 2 columns on the right are spanning the 5 rows of the explicit grid, and they're using multicol inside that wider 3FR column. The second row has a minimum size of 50 pixels, but it's got some content in there which is taller than 50 pixels, so it just expands. And it's worth remembering that in a 2-dimensional layout method, which grid is, that's going to happen all the way across the row. The row is also going to expand if the multicol section becomes taller. It's going to essentially blow apart the stuff on the left because we need some extra space for our text. So something like this. So we've now found that the empty track, which should be 50 pixels tall, is kind of stretched out to allow for the space for the longer content. Which means we can have a very simple set of row tracks, which if we don't have a lot of content will look very neat. But if more content gets in, and such is the way of the web, we never quite know how much content is going to get in or how big it's going to be, it responds and we don't get overflows, we don't get stuff overlapping each other. So that's pretty cool. And it's by understanding sizing that we get to do these interesting things. Digging into sizing doesn't seem that interesting. Learning the cascade doesn't seem that interesting, but it lets you do the interesting things. It lets you play with the interesting stuff that you can do. Kind of learning these fundamentals are kind of the CSS equivalent of eating your vegetables, getting enough sleep. And if you write CSS or design things that are laid out with CSS, I really believe that sizing is key. If you want to be able to take advantage of what we've got now and all the things that are to come. So something else I hear a lot, in my inbox or on Twitter or in person at conferences, they say grid is very complicated. There's a lot of properties for grid. Why is it being made so difficult? And this is a general problem with any software development, and developing new CSS is very similar to developing software. People want fully featured, but they also want really easy. And that's kind of a problem because typically more capability, more flexibility does mean more stuff to learn. But it has to be said, there's a whole bunch of interesting stuff defined in the grid specification, and then add to that, all the stuff that's in sizing or in box alignment. I can see why it looks overwhelming. But remember, you don't actually need to learn all of it. Many of the features of grid are really just different ways to do the same thing in order that it can fit into different workflows. And once you've kind of switched your mind to a grid way of thinking, you can just pick the bits and pieces that you want. And there's something really important to remember. Everything just sits on top of a grid of lines. If you learn about where the lines of your grid are and how to position things on those lines, all the other methods are really just kind of sugar on top of that. They're just a different way of doing it. So let's have a look at how this kind of all spreads out once we look at the lines. So here's a very, very simple grid. The layout is going to look like this. And if we put our lines on top, you can see I've got a grid here. It's got 5 column tracks and 4 row tracks, which gives me 6 column lines and 5 row lines, because we end up with the lines on the end as well. I'm working in English, so column line 1 starts on the left and numbers across the grid, and row 1 starts at the top and numbers down. So those are our grid lines. There's the grid definition and the line-based positioning of that item that's plonked in the middle of the grid, from line 2 to 5 on the columns and line 2 to 4 for rows. Now I could name some of those lines. So I've done that here and used the names to place items rather than the numbers. So here I'm naming my lines inside square brackets, giving them names of content start and content end for rows and columns. Then I've switched out, and rather than using the numbers when I'm placing my item, I'm using my new names. Now this gets kind of interesting, because you don't need to call the lines something dash start and something dash end. You can call them anything you like other than the word span. But if you do, you get a named area of the main name that you used. So because we've got content start and content end for rows and columns, that gives us an area defined by those lines called content. And rather than place our item via named lines, we could instead use the grid area property to do so. So I define my lines, then place the item with grid area content. Now that kind of magic grid area is less magical than you might think, because what grid area actually is, it's a shorthand for listing all 4 lines at once. Grid area content is really a grid area content, 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 content. And the order of the lines in this shorthand are grid row start, grid column start, grid row end, grid column end. And the reason those are all set to content is that when you've got a grid area, which we created from our lines, you also get line names created by that grid area of the main name used. So if you specify grid column start as content or grid row start as content, that will resolve to the start edge of the content area. And if you say grid row end or grid column end as content, that will resolve to the end edge of the content area. So now each of our lines has got 2 names, the content start and end that we gave it, plus the line name content. And the reason it works that we can just say grid area content is due to some specific wording in the grid spec, which tells you what happens if you don't specify all of your lines. And typically we have shorthands in CSS, and if you don't specify everything, the spec will tell you what happens. So this is what happens. If we specify only 3 lines, so we miss out grid column end will be set to the same value as grid column start, which is the line named content, so it resolves to the end edge of the area named content. If we specify 2 lines, so we miss out grid column end and grid row end, then grid column end will be set to the same value as grid column start, and then grid row end will be set to the same value as grid row start. And once again, that's going to be the end edge. So now if we specify only 1, all of the values become the same as grid row start, so we'll resolve to the start and end edges respectively. And that's why the grid area property works. It's just a shorthand way of specifying lines. And to complete the picture, we can create a named area using grid template areas and not name any lines at all. However, all grid area is doing is placing the item in the same way. at the start and end of the area named content that we've defined using grid template areas. So we've created an area named content, and we now have lines named content. And we also have something else. Because if we want to position something using a named line at the end of the content area, we can't use a line named content. I can't use grid column start content because that would put it at the start of the content area, because that's what grid column start does. And in this example, because we've just used grid template areas, I don't have the named lines I had in my earlier example. Or do I? In fact, I do. Because if you create an area with grid template areas, you will also get a named line of the main name you used, in our case content, with start and end appended for both columns and rows, which means we can position our item using grid row content start and grid column content end. Like that. And that will put it at the end. But it is all just a grid of lines. And there's a whole bunch of complexity built in there so you can do interesting things. And I think actually we've probably not figured out why we might want that yet. But if something is appearing in an odd place, go back to what line it thinks it's on. Because everything else is kind of just a choice you have if you want to use it. And this is the thing, you know, we actually have choice for the first time in terms of really how we do layout. We're not just thinking what will work. It's like, well, which of these things might I use? You know, which would be the best way to do it? And if you are starting a brand new project today, then take a good look at what's actually available to you now. And forget your assumptions based on what was not possible in the past, because things have changed. We can look at the best methods for achieving design patterns. We can think, well, you know, could we actually come up with a new design pattern here, a different way of solving this problem? We certainly don't just have to pick from a selection of options that our framework gives us. We don't have to just pick from the things that are constrained by some very, very limited technical limitations. And you know, this is all very nice, but I know from experience that many of you are sitting out there thinking, well, this is fine if you want to do a shiny new thing, but I work on an existing thing. So hands up if the CSS in your project, if you've got CSS in your project which is older than 5 years, it was written more than 5 years ago. Yeah, a few people. Anyone got CSS that was written more than 10 years ago? Yeah. Anyone still got some tables for layout in there? Yeah, you see? Right. You know, we're working on stuff that's been around a long time. In my survey, you know, I asked the same thing. And out of, 368 people working on existing projects, 29 of them had CSS in their code base that was written 10 or more years ago. So old CSS in your project doesn't mean that you can't use new CSS. The existence of old CSS doesn't mean that you can't start to use some of this interesting new stuff, because I imagine that sometimes you need to add a new component, perhaps some feature of a site. Perhaps everything really needs to sit inside this framework that you've got, that all of your stuff needs to sit in, but sometimes something comes along, you think, well, actually, we could take a chance, we could do something a bit different with this. And that's where understanding CSS comes in really useful. If you've figured out how the cascade inheritance works, you're in a position to understand which things will leak through into your component, what you might need to overwrite. If you've figured out sizing, you can play a few tricks to ensure that your CSS grid component can sit inside an older layout and still line up neatly. Now, I'm kind of expecting my next slide is going to result in all the other speakers racing on stage and dragging me off for some kind of comedy pantomime hook, because here is Bootstrap on the event part stage. But that's because I wanted to show you something. What I've got here is a layout that uses old Bootstrap, version 3 Bootstrap with the floated grid. And I've used the sort of standard methods to position the sidebar and content, because I wanted to take an off-the-shelf thing, something that was like the sort of CSS that's in a lot of projects. And I just dropped this grid component into it. So using CSS Grid to create a gallery that has things spanning tracks, that's nice and responsive, you can have a look at the example online, Some things sort of all ordered in nicely with grid, using auto placement. It works really nicely. It's absolutely fine. It works perfectly well inside that Bootstrap layout. And that's all the code I needed to add that component into the Bootstrap layout. So we can take advantage of new stuff within our old stuff. Don't feel like it has to be all or nothing. You don't have to rewrite your entire project to use grid layout. You can just say, hey, this little piece that we've got to add here, this would be a really good way to start using grid. You don't need to throw everything away. But if you are in a position to start a brand new thing, or even if you're doing some extensive augmenting of an old thing, you now have all of this neat stuff to play with. You can make decisions about how to use it. That means you can look at any component in your site and ask yourself which layout method suits it best. And something I have found is that often people embracing a new layout method, they kind of forget that there are still use cases for the old ones. And I remember seeing this when we moved from using tables to using CSS layout. People got this idea that tables were really bad and started trying to lay out their tabular data as a set of divs. Now, the same is true for floats. I've had a number of conversations with people who are trying to reinvent the float with grid. If you need a float, if you want that wrapping behavior, a floated item, then use a float. If you don't, then you might want to define a grid on the container or turning it into a flex container so that the items can be laid out in 2 columns. Multiple column layout might be a really great choice if you just want to collapse a linear list of small things into equal columns, like these checkboxes. This is a really good use of multicol. It responsively collapses down sections of UI. Flexbox. If you've got a bunch of things you just want to equally space along a row, you've got a bunch of stuff you just want a kind of a good sizing of all the items so that the text just displays in a nice readable way. Flexbox is ideal for that. You don't need to sort of force everything into using grid layout because you've started to use grid layout. It's one of a set of tools at your disposal. And something that has happened, I think, as we've relied a lot on these frameworks and other people's code, we've ended up absorbing solutions for problems that we don't have into our own code bases. Because off-the-shelf code just has to be really generic. It's got to solve as many problems as possible so that everybody will use it. And I don't know about you, but I don't want my project to inherit everybody else's CSS problems. I like to just solve the ones that I have. And you can start to replace the convenience factor of using something like Foundation or Bootstrap with your own layout utilities. And so instead of inheriting all of those problems, we're able to solve just our problems. And this is kind of really interesting and fun to do, even if you're just doing it on a very small level and just picking at bits of your project to do this on. Something I built earlier in the year has got a variety of things to lay out that kind of suit different layout methods. So some of them are nice in multicol, some are flexbox, some are grid. But what I do want is everything to line up. So if I've got a multicol element and then some flexbox, I would like the gaps between the elements to line up nicely. And so I wondered if it would be possible to create a Sass mix-in that I could throw a layout type and a size at and get the layout I wanted and all the sizing be correct. And here it is. If you don't use Sass, it might look a bit obscure. But essentially, this is a Sass mix-in called gridded. I passed a type of layout, grid, flex, or multicol, plus some information about the size I'm aiming for the tracks, flex items, or columns, plus the gaps between them. It then creates my CSS. The flex output is the most complex because I have to deal with the flex children, the child items before, to get the layout, whereas everything else, multicol and grid, acts on the container. And that's how I would use that in my Sass when I want to create one of these layouts. And that's an example there of the 3 types. You can see they're sort of matching in terms of spacing. Now that's really, really specific to something I'm working on, and it's not a perfect solution for everything, but that's the point. You don't need to lean on someone else's code, someone else's framework. Come up with your own stuff, with tools and utilities that do exactly what you need, solve the problems that you have. But then I do need to come to the issue of browser support, because I've discovered that if I don't talk about browsers from up here, you're going to all come and talk to me about browsers out there. So we might as well kind of cover this while we're all in the room. So in 2006, Yahoo, who at the time had many of the leading minds on the web working for them, they published this chart and blog post. It was written by Nate Ketchley, and it detailed something they called graded browser support. And this was a companion to the YUI, the Yahoo User Interface Library. They made that available. It was I guess one of the earlier sort of JavaScript-type frameworks for doing components. And they also made this graded browser support stuff available so that it would explain the choices they'd made, and it would explain why they were doing browser support in a certain way. And what graded browser support did is it categorized browsers into up-to-date modern browsers, which at the time included IE6. This was a long time ago. And those ones should get all of the features in the YUI. So every sort of cool feature that was going to be there, that would be available to those browsers. And then there was kind of ancient browsers, which were going to get kind of minimal support or what have you. And then there were these sort of unknown browsers, where we don't know what these things are. And you think about it, this was 2006. There were far fewer things out there than there are now, but that's what they were doing. And this graded browser support thing was really useful as someone developing websites for clients. Because one of the problems, I think, when we talk about browser support, and this goes right back to just using CSS for layout, over 15 years ago. These conversations often happen with a lack of understanding on one side. So your client, your boss, your team member doesn't understand that it's possible to support all browsers while providing different experiences to them. And so you've got this lack of understanding. And then on the other side, perhaps on the developer side, you've got a bit of a lack of confidence. As a developer, you know that you can provide these good experiences. You know that things don't all have to look the same. And you're pretty sure that this progressively enhanced approach that you hear about is possible, but maybe you don't have the resources or the examples or the confidence to make the arguments. And graded browser support basically gave people this chart. You could say, well, if Yahoo, which at the time was the most trafficked homepage on the internet, if Yahoo was saying, we're dropping this browser, we're downgrading it from being a grade A browser, you could say, well, if they're saying that's okay, then it's okay for us too. And it was hard to argue against that data. Actually, I grabbed that copy from the Internet Archive. The graded browser support page is no more, sadly. It's sad how we're losing all these bits of our history. But so I was thinking about this, and I was thinking it would be useful, if we had something like the graded browser support now. But really, it has to come from us. Building confidence in our CSS skills actually allows us to make those same cases. If you think that CSS is this kind of scary language that blows up all over the place and breaks all the time in different browsers, then it's going to be very hard for you to make a case to people that, oh yes, it's perfectly safe for us to be using this. And as you learn more, I think a lot of the time you'll find you don't need to make so much of a case up front, because you'll be able to come up with solutions in terms of the different browsers you need to support and demonstrate that they work, demonstrate that they support the business case, because that's usually what this comes down to. What does the business need? What's the best way for us to sell our product or for people to use our application? If you can show that what you're developing supports the business aims, no matter which browser the visitor is using, that's kind of the key thing. So we'll have a look at some of these old browsers. For most people, old browsers means Internet Explorer and probably IE10, 11. In my survey, 39% of people were saying that IE11 was the oldest IE that they were supporting. But if we add IE10, 11 together, we say 63% of people were saying, we need to have really good support for these browsers. Now, what I'm not going to do today is go through a whole heap of code for browser support. I've written a lot about it. There's links in the show notes. But if IE10 or 11 is your lowest supported version, you've got a couple of options. You can potentially use the older Grid Layout implementation. Grid came from Microsoft. There's an earlier version, which is MS Prefix, shipped in IE10 11. It doesn't have auto placement. It doesn't have grid template areas. The syntax is a little bit different, but it's certainly possible to use. I would only suggest using it if you have a very, very high level of users of those browsers, because they're going away. If you're writing something new now, Unless you're in very specific market areas, you're probably finding that those browsers are starting to disappear. I would suggest doing a fallback that works for anything that isn't a modern browser that doesn't support Grid, rather than specifically targeting i1011. But there are some people who have products that go on the desktops of people who are never going to upgrade or aren't going to upgrade for the next 5 years or whatever. Well, maybe it's worth looking at that, and it is out there and you can use it. If we look at people's reported support of other browsers, a lot of people said, oh, we only support the latest version of Chrome or Firefox. No one seems to actually know which version's which. And maybe the last 2 versions is most common. So saying, well, I support the last 2 versions of Chrome, the last 2 versions of Firefox. So the thing is, we know about old browsers, and you can code round lack of support. But there are browsers that might never get Grid support. There are people using devices that won't update to those new browsers. And even as those old browsers go away, new features are going to emerge. We're never going to be in some sort of position where the CSS working group invents some CSS, and the next morning, everyone on the planet has it on their computer. That's just not how it's going to work. So you're always going to be dealing with this situation. If we look at Grid, the CSS working group are already working on Grid Level 2, which is all about implementing the subgrid feature. And this is kind of our most requested feature for Grid. So if we had a grid like this, like the grid we were looking at earlier, and we've got the item there positioned on the grid, and if we turn the columns and rows into a subgrid, so we're saying display grid on the child, and then we're saying that the columns and rows are a subgrid, then what you're saying is, I'd like to use the tracks that are defined on the parent, so the outer grid's tracks for my inner item. The subgrid can then use the lines of the parent, so the indexes work from 1 just like any other grid. So if that purple box was a child of item, which is the grey subgridded area, we would place it from column line 2 to 4 and after row line 1. So here, instead of creating our own tracks in our grid, we're using those from the parent. Now that'll be very cool. It's our most requested feature for Grid. And although we hope it will ship really quickly cross-browser, it's going to have people in a situation again where they've got all these browsers with Grid, and oh, I'd like to use subgrid, but oh, it's only currently in Firefox or whatever. So it's all going to happen again. And this is going to keep repeating with new things. There's always going to be someone or something lagging behind in upgrades. It's how the web works. And if we step away from the future for a while and look at the past and add some lesser-known browsers to Can I Use? So this is a screenshot from December last year. And the key browser I want you to look at is the mention of UC browser for Android. Who has heard of UC browser? A few people have heard of UC browser. But if we switch it to usage relative, you find that that browser is more used than you might think, even if you've never heard of it. And it turns out that worldwide it has just under 8% market share. In India, it has 35%, coming second only to Chrome. This is a massively used browser. And that's the thing I really want to talk about when it comes to browsers that don't support Grid. A lot of those are mobile browsers. And even more importantly, a lot of those are browsers on devices popular around the world and in places where the devices are often less powerful and the data is expensive. And I wanted to call that out because of something I hear over and over again, and it came up in my survey. People are looking for the magical Grid polyfill. I get asked about it all the time. People would like to be able to write Grid code, drop in some JavaScript, and it will magically work for all of the old and non-supporting browsers. Please stop looking for this. It would be very, very expensive in terms of JavaScript to try and implement even the smallest part of Grid. Why would you force a load of JavaScript onto the less capable device? The important thing is how can that customer get the information that they've come for? That is the most important thing. The customer is not A/B testing your website. They're not checking whether your site looks identical in 2 browsers. They just want to get to the information or buy the widget. And the search for a magic polyfill really misses a key point of these layout methods. They give us this amazing opportunity to create lighter, quicker, less expensive in real monetary terms websites for much of the world. We can use our shiny new CSS to make the web better for people who don't support shiny new CSS. That is just super cool. CSS has developed features such as feature queries that make this easier. We don't need to load in the JavaScript of Modernizer to test for grid support. We don't need to sniff for browser versions, which of course would leave us completely forgetting about something like UC Browser because most people hadn't heard of it. We can use CSS alone to enhance CSS. Because the cool thing about doing that, the cool thing about testing for grid support using feature queries, is that when this happens, and UC Browser updates and those people start to get grid support, they're just going to get the cool version of the layout. They won't need to download anything new. It was there waiting for them all along. And it's worth remembering that as we celebrate another browser that gets grid, and it is worth celebrating, there will always be browser X. There will always be the unknown, the one you've never heard about. There will always be the people who can't or don't update. And many people won't be able to get the new version of UC Browser because they're stuck on old Android phones. By using our new methods responsibly, we get to support that browser and its users wherever they are. Our new layout methods are elegant. They work with feature queries. They're designed to overwrite older layout methods. Adding that support adds just a few lines of CSS, which isn't going to have a huge impact on a browser that doesn't get the grid layout. By using your skills in layout, you can start out by creating a very simple experience, and then with a few lines of CSS, turn on your fancy grid layout for those with support. Those few lines of code aren't causing a problem to limited devices. What will cause them a problem is if you try and load in a whole load of JavaScript in order to give them the fancy layout. And you know, being able to do cool new stuff is great. I love new stuff. I love new CSS. It's great. Being able to save developer time is fantastic. You know, that lets us move on and do more things. But making the web available to everyone, that has to be key. I've never wanted to be building shiny, cool things just for rich people. I want to play a little part in a web that perhaps enables a person in India who can only be online for short bursts to get information, to learn, to look for work, to be part of this. I wouldn't be part of this if it hadn't been accessible and easy to get into and cheap to get into when I got started. So it's never been about the new shiny for the new shiny's sake. I'd have got bored a long time ago, really, if it was. And I'm going to wrap up by going back to that survey I mentioned at the start and all of those downbeat, sad responses. And I'm glad to say they weren't all of the responses. And in fact, they weren't the majority of responses. There were a lot of people who said they were excited, which is exactly what I want you to be, for a whole host of reasons. And I think the next two talks will really help with that. So thank you very much for listening today.